Hi, let's solve one previous question of topological sort. This question was asked in GATE CS 2016 set 1 question number 11. Consider the following directed graph. The number of different topological ordering of the vertices of the graph is dash. This is the directed graph. I already discussed topological sort. There I discussed two algorithms. One is Dfs based algorithm, another is source removal algorithm. Let's first do Dfs based algorithm. We'll start from A. So discovery time will be 1, then B discovery time will be 2, for C discovery time will be 3, for F discovery time will be 4. Now this is a dead end, so we'll backtrack. Now finishing time will be 5, for C finishing time will be 6, for B finishing time will be 7. Then from A we'll visit D, discovery time will be 8, then we'll visit E, discovery time will be 9. Now this is a dead end, so we'll backtrack. Finishing time is 10, for D finishing time is 11, for A finishing time is 12. So we got the topological ordering A, D, E, B, C, F. Suppose after A rather than B we'll visit D. Now A discovery time will be 1, D discovery time will be 2, E discovery time will be 3, F discovery time is 4. Now I'll backtrack. 5, E finishing time is 6, D finishing time is 7. Then from A we'll visit B. B discovery time will be 8, C discovery time will be 9. Next C finishing time will be 10, B finishing time will be 11, A finishing time will be 12. So got another sequence A, B, C, D, E, F. Start with A, end with F. In between D, E, B, C, B, C, D, E. We got two sequence by Dfs based algorithm. I already discussed that by source removal algorithm we may get more topological ordering, and here it is asking number of different topological ordering. It is not asking about DFS based algorithm or source removal algorithm. So we need to check all possibility and we need to write maximum possible number of topological ordering. By DFS based we got just two topological ordering. Let's apply source removal algorithm and see how many topological ordering possible. So for source removal algorithm, we need to take in degree of every vertex. In degree of A is 0, in degree of B is 1, C is 1, D, E are 1, F is 2. So first we will remove A with its outgoing edge, and in degree of B will change to 0, in degree of D will change to 0, and we'll insert A in the queue. Next, from B and D, we can choose any one. Let me choose B. If we'll remove B, in degree of C will change to 0. So we'll insert B in the queue. Next, from C and D, we can choose any one. Let me choose D. So if we'll remove D, then with D we'll remove its outgoing edge. So E in degree will change to 0 and insert D in the queue. Now from C and E we can choose any one. Let me choose C, so we'll remove C with its outgoing edge. In degree of F will change to 1. Insert C in the queue. Next source is E. With E we'll remove its outgoing edge, so in degree of F will change to 0. Next we'll remove F. So we got this sequence A, B, D, C, E, F. This sequence. There are also multiple sequences, like from B, D we can choose any one. From C, D you can choose any one. From C, E you can choose any one. So first vertex will always be A, last vertex will be F. Then there can be B, C, D, E. Then it can be B, D, C, E. It can be B, D, E, C. It can be D, B, C, E. D, B, E, C, D, E, B, C. So there are total 6 sequence possible. We need to arrange in such a way that it will start with A and with F, and in between there can be B, C, D, E. B should be come before C, D should come before E. So there are total 6 possibility. We can also check by combinatorics. So start with A, end with F. There are 4 vertices in between B, C, D, E. And also there are 2 conditions that B should come before C and D should come before E. 4 vertices, so 4 factorial divided 2 factorial multiplication 2 factorial. It is 6. So there are total 6 topological ordering possible. I also discussed another method, that is tree construction method. We can construct a tree-like structure to find topological ordering. Start with A will take as a root. Then from A, either you can visit B or D. So there will be 2 child B or D. Next, from B, either you can visit C or D. So C and D will be B child. Then from D, either you can visit B or E. There are 2 possibilities. Suppose we visited this A, B, C. Means A, B, C. So next we'll visit D. After D we'll visit E. Then we'll visit F. So D, E, F. Next, after A, we visited B, then we visited D. So after D, there are 2 possibilities. Either you can visit C or E. So C or E. If we are visiting E, next we will visit C, then F. If we are visiting C, next we will visit E, then F. Suppose after A, we visit D, after D, we visit B. Then after that, there are 2 possibilities, either C or E. So let me first visit E. Suppose after B we visit E, then we'll visit C, then we'll visit F. Before F, C should be visit. Suppose after B will visit C, next we'll visit E, then we'll visit F. Suppose after A we'll visit D, then we'll visit E, next we'll visit B, then we'll visit C, then we'll visit F. So these are the topological ordering. This is our first topological ordering, second topological ordering, third topological ordering, fourth, fifth, and this is our sixth topological ordering. There are total 6 topological ordering. Either you can apply source removal algorithm, or you can apply the combinatorics method, or you can create a tree structure for finding topological ordering. In any way, maximum number of topological ordering is 6. So answer will be 6. I already discussed topological ordering. Just go through that lecture. You can easily solve this question. And if this lecture is helpful for you, please like and subscribe. Thank you.